Hey, what's going on, everybody? Alright, we're continuing to use the sine rule. And in this video, what we're going to do is we're going to focus on word problems, and you're going to learn to solve trigonometric word problems using the sine rule. Now, earlier in the chapter, we learned how to solve some profile view and map view questions using right triangle trigonometry. And now what's going to happen is we're going to be able to solve the same types of equations, but ones involving non-right triangles, or at least we're going to be able to use non-right triangles to help us solve more quickly, even if other right triangles are involved. You'll see what I mean here. We got one problem in this video because you've seen all the types of problems before. It's just a matter of now seeing it with the sine rule involved. Okay, so here's the problem we're going to work on. It says a surveyor is measuring the height of a hill. He notes the angle of elevation of the hilltop from his initial position is 11 degrees. He then moves 100 meters closer and notes the angle of elevation is 32 degrees. Find the height of the hill. Now this is a really clever surveying technique actually. Surveying is, well, just a way of measuring for engineering purposes or whatever kind of purposes you have, by the way. This surveyor has come up again with a clever strategy of finding the height of the hill. Now, first of all, let's say that this is the hill right here. Alright, and then this is the ground. And let's say that the surveyor starts at this point right over here. And the angle of elevation, he notes, of the top of the hill from his initial position is 11 degrees. Okay. So he's able to see what the angle of elevation of the top of the hill is because the surveyor would have a tool to be able to do that. Then what happens is he moves 100 meters closer. So let's say that this point is 100 meters closer. And he again measures the angle of elevation of the top of the hill. And he finds this time that that angle of elevation is 32 degrees. Alright, 100 meters. Now, let me explain why that was clever. Look at what the surveyor was able to do. He is able to create an angle-side-angle triangle. This one right here. Now, you say, that's only an angle on a side triangle because I only know one of the interior angles and I know one of the sides, but these two angles right here are supplementary to one another, right? So actually, this surveyor knows two angles. He knows he's got a non-right triangle with a 148 degree angle and an 11 degree angle. Okay, well, how is this going to help him find the height of the hill? I need to draw on the height of the hill. The height of the hill would, of course, be this vertical distance right here. Alright, I got a right angle there and everything. H is what we're trying to find. Well, here's what we're going to do. We're going to try to use this non-right triangle that I've outlined in pink to help us find another side on this right triangle with which H is one of the sides. Okay? In particular, I'm going to find the side that is shared by that right triangle and the non-right triangle. I'll label that simply as X right here. And I'll be able to find X using the sine rule. And then if you look at the right triangle here, I'll be able to make a ratio between the opposite leg from that 32 degree angle and the hypotenuse. So I'll just be able to use a typical old sine ratio in order to find the height of the hill. You're going to see this is an easy two-step process. Alright, well, let's go ahead and use the sine rule to find that value of X. We know the angle opposite from X is 11 degrees. That's good. We also know one more angle measure and one side length, but you see how those are not opposites of one another? Well, that's easily remedied since we know these two angles add up to 159 degrees. We can figure out that the angle way up here is 21 degrees. And now we know another angle and an opposite side length. So we're able to use the sine rule now, right? Okay, so X over the sine of 11 degrees would equal 100 over the sine of 21 degrees. Now go ahead and use your calculators, figure out what you get for x. And what you see is that x is about 53.2 meters. Now keep the exact value on your calculator, but I'm going to write down 53.2 meters through significant figure measurement. Okay, well now that we know that this distance x is about 53.2 meters, let me go ahead and put 53.2 there. We can do what I said earlier. We can find out what h is using the right triangle, and we can use a sine ratio. The sine of 32 degrees would equal h over 53.2. Well, I'm going to write h over x, and you can just use your exact value for x that was on your calculator. Right? Then h would equal whatever x is times the sine of 32 degrees. So plug in your value of x, multiply it by the sine of 32, and you find out that the hill is about 28.2 meters tall. And you just, since you introduced all the variables here, let's just go ahead and write out a little sentence here that says what you found. The hill is about 28.2 meters high. Alright, so there's an example of how you can take the same types of trig word problems that we've been working on and solve them more simply using the sine rule and non-right triangles rather than having to use right triangles only. Not so bad, right? Alright guys, thanks for watching. See ya.